Who was that?
It's in the chat. Oh,
Okay, I see.
yeah.
Hold on one second. Yeah, try to get in. It, you know, please try to get. If you want to record, please try to get in on time. Does everyone have permission to record that wants to record now? Let's see. Okay. All right. Okay, so yeah, try to get in on time, especially if you want to record. And maybe you did, and I just didn't do it. All right. So a differential equation that's separable is that you can write it as some function of g, right, times some function of y. Okay. And then in the process, you could put your function of y here, and then dx, your function of g here. No, I should put the dx on the other side, and then integrate both sides. Many times physicists will actually put the dx here as opposed to here. It doesn't matter. All right, and then you integrate both sides. So an example, let me do an example. Now I'll do the same example. It's in my notes. Let's say that that g of x is equal to minus 1 over x, right? And my function of y just happens to be y, right? Then the differential equation would just be minus y, right, over x, right? This is my g of x is minus 1 over x, and this is just y. So this is a separable differential equation, right? This equation, I could write it as, we could put the y here, put the minus sign here, and make this x dx, right? So I separated, I got the y on one side of the dy, I got the x on the other side of the dx. And now if I can integrate both sides. So many times doing separable differential equations, it requires us to go back to calculus 2 when we do integration. So now I integrate both sides. Oh, this is 1 over x, right? It's 1 over x. Okay, so now I integrate both sides, and we all know that the integral of this, right? This is just the natural log of y, and this is going to be minus the natural log of x. Now I have to put a constant, right? So I'll put a constant c. All right. So now what? All right. So now, if I want to get an explicit solution, I got to solve this for y, right? An explicit solution means I got to solve this for y. So if I solve this for y, I take the exponential of both sides, right? When I take the exponential of both sides, I'm going to get y is equal to, let's see. Yeah, okay, I may do it a little bit different. It's in my notes. Let me write it as y is equal to e to the minus over x plus c. Okay, now these are not the inverse of one another. Okay, I want to make this clear. If I want to take the inverse, all right, of this, if I want to figure out what this and this is equal to, I got to get rid of this minus sign. So in other words, this is y is equal to e to the natural log of 1 over x plus c, right? It's 1 over x plus c. And so that means that, so now these are the inverse of one another. These are I got e, and then I got the natural log. So these are the inverse of one another. So let me even do another step. Let me make this as y e to the natural log of 1 over x. And then I'm going to write this as e to the c, right? We add the exponents, right? So I can write this as e to the c. So I'm going to write this now as y is equal to, now e to the c is a constant, but so I could just write this as c, the natural, so I'm just going to write e to the c as c, because that's also a constant. And then this is now the natural, let's see, So this is, yeah, okay. So let me continue doing it. Let me not skip a step. I was going to skip a step. So this is now, I can write this as e, the natural log of 1 over x, right? And that now this here, e times the natural log of 1 over x, this is y is equal to c. This letter is driving me crazy. Y is c. And then this is e, this is just 1 over x. So I can write it like that, 1 over x. All right. So this is the solution to this differential equation here, right? It's a solution to this differential equation here. Now, let's see. This also could be written, right? This also could be written as y prime, right? The differential equation here, I can rewrite it as y prime is let's see, y prime is equal to x, right? I can x plus y, right? You bring the y over, right? So you can write this differential equation like this. The reason why I want to write it like this is I want to show you this is one of the differential equations. If I go back, remember this here? We talked about this. I guess we talked about this maybe the first day, right? That if I have this differential equation, right? So this is the differential equation we just solved. This is a separable differential equation, right? And one of the solutions, right? One of the solutions to this differential equation is 1 over x, right? And there's a whole family of solutions, right? Any value of c would be a family of solutions that would satisfy this differential equation. So we just solved this differential equation by using the method of separation of variables. And we all know that the largest interval, right? The largest interval will either be from where this is defined, right? I can't divide by 0. So the largest interval will either be, you know, from minus infinity to 0, where we have to use the parentheses, right? Is using interval notation, and or this, right? So this is not, yeah. So -3 to -1 is a valid interval, right? These happen to be the largest, and we can't have an interval that includes 0. So in other words, in this case here, once again, if I had a -3 and a 2, right, that I couldn't. This is going to go through 0, so you can't. This is not a valid interval. Okay. All right. So we just solved this differential equation, right? You see, I could bring the x up here, and then right, and then bring the y over to the other side. Okay. All right. So that's a separable differential equation. I want to do another one now. And turns out this other one, I actually have a video on. So let's see. Come on, why is it? You're seeing my screen now, right? Let's see. Integrating factor. Okay, separate.
Yeah.
Okay, it's in my notes, but okay. What I want to do now is I want to solve this differential equation with it. So I assume everybody's seeing the video, right? Okay. This initial condition. Right, this is a separable differential equation. By a separable differential equation, I have this dy here. So everything that's a function of y, I can get on the same side of the equation as dy. I have this dt here, and everything that's a function of t, I can get on the same side of the equation as the dt. So that makes it separable. and then we just integrate both sides, and we just use our techniques of integration to solve the differential equation when we have a separable differential equation. Right. So let's see how to do this. What I want you to do, I want to give you like 5 minutes to try to solve this yourself. Okay, and maybe you'll have some trouble with it, but then once you'll see it, you'll definitely all know how to do it. All right, so I want to give you about 5 minutes to try to solve this equation. You may not finish it in 5 minutes, but see if you could figure out the approach and how you do it. As we start doing more and more problems, I'll be doing things like this more often, where I'll ask you to try it first, and then I'll do it afterwards. Because I figure I always feel that I can learn from my mistakes. I make lots of mistakes, and I can learn from them. But that's the key thing. It's okay to make mistakes, but just learn from your mistakes. I'm glad to see that the attendance is good. You know, historically, the students that come to my class, you know, that come all the time, normally do very, very well on the exams. This problem here, I actually gave this problem on an exam.
Professor, I have a
Yes,
question.
sure.
So I kind of like know how to start it a little bit, but then I get stuck.
Okay. Well, that's all right. Um, I'm gonna do it, so you'll see. But I want you to get. I shouldn't say I want you to get stuck, but
Okay.
after you get stuck, hopefully you're gonna see how to do it. Okay.
Oh, okay.
All right. That's basically the idea. You try and maybe you get stuck, and then once you see how to do it, it's now I see how to do it.
No, it's like I get stuck, but then I have an idea. Like when I like get it to the second step, am I supposed to multiplying the two into like the parenthesis to be able to go move on to the next step or no?
You don't have to do it that way. There's many times there's more than one way.
Okay, and then I will just wait.
Okay. Okay, I'll give you another minute. All right, let me go ahead and solve this problem. And hopefully, if you had trouble with it, that now you're going to see how to do it. So let's see. So first of all, I got my dy, and I'm going to bring this, I'm going to write it like this. I'm going to write this as minus. Okay, so everybody see what I did? I brought the dy down here. I brought this over to the other side, so now you got this minus sign here. So now all we have to do is integrate both sides. Here I got y, right? I got my dy and my y, and here I got t and dt. So if I integrate both sides, okay, hopefully everybody sees what I just brought the dy down here, and then I took the dt and brought it up here, and I brought this over to the other side of the equation. Okay, so now let me just rewrite it over again. I want to give myself some room here. Put the -2 here, leave a space. Okay, so what I'm going to do now is just integrate both sides. All right, now this integral is, let's see, it's y to -1, minus. I always find that it's easier to do, when you have simple integrals, it's easier just to figure out, what derivative will give me this integral, right? If I take the derivative of this, bring down the -1 times the minus here, that gives me that gets rid of the minus sign, and then you -1 and you get the -2. So you can see the derivative of this gives me this. Okay. All right. Hopefully everybody knows how to do these simple integrals, right? Now here I'm going to get -2. And then when I take the integral of this is just t squared over 2 plus t. And then I'm going to add this plus c. Now, you could have just brought the 2 in here. It doesn't matter. But, the 2 is just a constant. I can leave it outside the integral. I could have left it inside the integral, right? But, I sure hope that everybody knows how to do simple integrals like this, right?
Professor.
Okay. Yes. Hold on. Yes.
Oh,
Yes.
I'm sorry.
Right.
So like for
No,
me.
let me stop the video. Go ahead.
Oh, okay. So for me, I think it's like the reason why I got stuck in the beginning is because I like do it different from you. Like how I adding an extra step for my work, which is like how I see it. I just like subtracting like the whole 2t plus 1 and y squared to the other side. And then from there, when I see the 2, I was like completely stuck by it.
Yeah, but there's more than one way of doing these problems, as long as you're following the rules of algebra. But do you think you understand now?
Yeah, I think I see the pattern now. I think it's like what I get really stuck on is like the 2, which is like really trick me.
Okay. All right, let me continue. I'm just going to multiply through by the minus sign, get rid of the minus sign. Now I could leave this plus. I could leave this with plus c. It doesn't matter. But I'm going to make it a minus c. I think I left it a plus c in my notes, and you'll see we're going to end up getting the same result. So let me make it a minus c. I think in my notes I made it plus c. Okay. So I left it as plus c. Okay. So let's see now. All right. So I can rewrite this like this now. This would be t squared plus 2t minus c. Now, I can write this as, let's see, write this as y You write this as 1 over, just take the reciprocal of both sides. So that's it. So this is my, this is the general solution to this differential equation, okay? Now, let me put in the initial conditions. This is my initial condition. Okay, so this is going to be, let's see, this is minus 1 over 24, right? So I have to substitute 0 in here, right? So this is going to be 0 plus 0 minus c over 1. So I'm getting that minus 1 over 24 is equal to minus 1 over c. So c, I'm getting c is equal to 24, right? C is equal to 24. So my solution to the differential equation that satisfies the initial conditions is t squared plus 2t. Now here I got a minus c, but c is 24, right? So it's going to be a minus 24. Once again, I think in my my notes, if I remember right, when I did it in my notes, I made this plus c, so that will make this a plus. But then you can get the reverse. Okay, so now I really wanted to stress this point is that when this is equal to 0, right, I don't have the valid solution, right? But if the denominator here is equal to 0, I don't have a valid solution. Let's see. So this here, this is equal to 0, I've got a problem. And notice it can be, right? But I could factor this. This will be, right, I can factor this, right? So I get t is equal to minus 6 in this case, and t is equal to 4, all right? So, okay, so when t is equal to minus 6, and when t is equal to 4, this is going to be discontinuous, all right? So my, the valid interval, right, the valid interval for this differential equation is going to be, let me actually draw a number line. Let's draw a little number line here. Let's see. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6, 7. So 6 is here, minus 6 is here, and 1, 2, 3, 4 is here, right? So this is my valid interval. Right? This is minus 6. This is 4. And the valid interval, no, my initial condition, right? My initial condition is t is equal to 0, right? So the valid interval is, in interval notation, would be minus 6 to 4. And it's important to realize that, you know, just a differential equation, you have different valid intervals, right? But the valid interval has to contain, in this problem here, the valid interval has to be within the, where my initial condition is. So my valid interval has to contain 0, right? My valid interval has to contain 0. Okay, I guess that's it. Any questions on this problem now? Hopefully, this is a problem that I actually previously has given on an exam. Most of the students, I think everybody, most of them got it right. Okay.
I have a question.
Sure. Now, here
why did you move the y over? Couldn't you just integrate it? Couldn't you just, after you move the 2t plus y, no, 2t plus 1 y squared over, couldn't you just integrate it with the y as a constant?
Repeat that again. Say that again. Are you talking about this line here? Which line are you talking about? This one?
The very first line.
Yeah, this one here?
Yeah. I know you moved the whole thing over the equal sign.
Right, I moved this over, right. I wanted to get the t on one side of the equation, the y on the other side of the equation. So I brought this over here, and then I brought up the dt.
I mean, couldn't you integrate without moving the y? Couldn't you just integrated it and
No,
use the
I
y as
can't.
a constant?
No, y is not a constant. I can't. I can't. No, you can't do that. I got to get all. The rule here is you got to get the y's all on one side of the equation and the t's on the other side of the equation. Y is not a constant, right?
Okay.
Y is not a constant, right? That's important to understand. What y is it's the dependent variable. It depends upon x.
Okay.
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 So so anyway, let me go back now. I guess I'm getting better at going back and forth here. See, this is what's in my notes, right? The same problem is in my notes. I just want to show you that, I made the C here. Yeah, I made this. I kept the C here to be positive. We're in my notes, where we're in the video, and I did this intentionally. I wanted to do it differently. So here I have a plus C, and in the video there's so here there's a plus C, in the video there's a minus C. But when you apply the initial condition, it's going to come out right. Okay, you're going to end up getting the same equation at the end. All right, just notice this. I should have minus signs here. Okay. All right, so this is so you got the video of this problem, and you got the problem in my notes. Let's try another one. Okay. I have a feeling some people are finding this real easy, and other people maybe finding it a little bit more difficult. If you haven't had, sometimes people take differential equations and they haven't done math in a while, or they haven't had, they recently. If differential equations is easy, if you've recently had calculus 1 and 2. If you had calculus 1 and 2 years ago, I find that students sometimes have problems, but we'll all get there. We'll all get there. All right. Let's see. I want you to try once again. I want you to try to first do this. Let me give you like 5 minutes and try to do this problem. Okay, because now what's up? So we have this differential equation, right? And this is the initial condition. And I want you to try to separate this out and see if you can solve this. Okay? Without looking at my notes. But if you're really getting stuck, you could look at my notes. So you have to understand your rules of exponentials, right? Let's see. I'll be back in a second. All right, let me go ahead and do this one. This one is, hopefully you found this one to be pretty easy if you understand how to work with exponentials. So let's see. Should do it where, okay. Well, see, I can bring this dy over to here. In other words, I can write this as dy, and then, well, let me not skip a step. Let me write it first like this, right? I could write it like that because when we deal with exponentials, right, we would add them here. So then I can bring this over to this side, right? So in other words, I can write this as e to the minus 2y dy. And then here I got, I'll bring up the dx, right? And I got e to the 3x dx. Okay? All right. Now I could integrate both sides. And what is this going to become? Right? This is going to become, when I integrate this is going to be minus, this is minus 1/2 e to the y, right? Because when I take, I got a 2 here.
Wait, Professor, I'm sorry to
Yeah.
interrupt. Is it the same thing, just like writing the dy divided by e to the 2y? Or no?
No, when I bring this over to the other side here, this here becomes negative over here, right? Yeah. If I write it like, we do it like this. This thing is driving me crazy. Right? I can write it like this.
Yeah, that's how.
Right?
Yeah.
Yeah, that's okay. And then you can integrate this if you want. But so then, but this is the same as this.
Oh, okay, I see. Okay.
Right?
Yeah,
Yeah,
I
there's
see.
more than one way of doing it. Okay.
Okay.
All right.
Thank you.
So here now, this is going to become 1/3 e to the 3x plus c. I always put my constant on whichever on the right side. And okay, so that's it. That's this is the general solution to this differential equation. Now, if I apply the initial condition, I'll be able to determine what c is. Right? I can determine what c is if I apply. We're told in this problem here the initial condition is y of 0 is equal to 0. Okay, so so they're both 0. So this is going to be minus 1/2 e, and then this is going to be e to the 0, right? 2 times 0 is 0, is equal to 1/3 e to the 0 plus c. E to the 0 is 1, right? E to the 0 is 1. So I get, let's see, so we get minus 1/2 minus 1/3 is equal to c, right? Minus 1/2 minus 1/3 is equal to c. So this is the same as, now we get a common denominator here. Now we're back in high school. This is 3/6 minus 2/6, which is minus 5/6. That's equal to c. So c is minus 5/6. Okay. So so c is minus 5/6. So my solution then, I can write as minus 1/2 e to the 2y is equal to, it's equal to 1/3 e to the 3x minus 5/6. And you could leave it that way. You could certainly leave it that way. Let's see. But there's other ways of writing it. Let's see. If I multiply everything through by 6, let's see, if I multiply everything through by 6, another way, just another way of writing it is, let's see, I can write this as minus, that'll be 2, and minus 5. And I'm just taking a look at how I have it in my notes. And then I could, yeah, I could bring the 5. And if I don't want to write it, I could also write it like this now. I can bring the 5 over here. But this is a good answer. 5, and then I can bring this over to here. Sometimes you want to write it without the fractions. So this is just another way of writing it. Okay. All right. So yeah, I'll answer your question in a second. So here's the problem worked out in my notes. I guess I did it the same way. So you see, we break it up, right? And then once again, we're getting the y on one side and the x on the other side. And then we're integrating both sides, right? Okay, someone had a question?
Yeah, never mind. It was just when rewriting the e to the 2y, you forgot the negative. I was just gonna remind you that on your paper. Not on this one, the other one.
I forgot the.
On the third line from the bottom, it was supposed to be -1/2 e to the -2y. Wait, if you go up 2 lines, yeah, here. Yeah, here. Shouldn't it be e to the -2y?
Oh, right. Good. Yeah, thank you. That's right. Very good. Yeah, I forgot the negative sign. Yeah, please, if you see I make a careless mistake, let me know. Copied that wrong. Okay.
Wait,
Good.
Professor, I
Thank
have
you.
a question
Sure.
about this problem.
Yes.
So you cannot actually set it like on one side and set it equal to 0, right? That would be so wrong. Is it?
Well, I mean,
When no, when you're trying to rewrite the problem, like on the very bottom.
right.
So how I see it, I just like trying to subtracting the 1/2 e to the power of -2y, and then just like add it to both sides, and then just like make it one side equal to 0
Yeah,
and
you
the
could.
rest.
I could make this -5 and make this equal to 0. It'll still be correct. Is that what you're saying?
Yeah, but I didn't really like I just leaving like the 5 divided by 6 just the way it is. But I
Yeah,
just
you
like
could.
subtract.
Yeah, you can leave it just the way it is. WebAssign should accept any WebAssign should accept any way you write this. You can try writing it in different ways and see what happens. It should accept it. Okay, I want to do now a problem that's a little bit harder. And let's see, where were we today? Well, I hope I have a feeling some students are finding this, like I said, if you recently had calculus and everything, normally this is pretty straightforward stuff. I want to do a problem that's a little bit harder. Not harder, but okay, once again, I'll let you try. It's important that you know how to do these. Let's see, today's Wednesday. So tomorrow I plan on doing, when it's solving first order differential equations that are not separable, the linear first order equations that are not separable. Okay. So, all right, I want to see if you can find the general solution to this. All right, I'm going to give you some time to work it. Now, I'll give you, you're going to have to integrate by parts. All right. One of the things you're going to have to know your techniques of integration. Integration by parts, partial fractions, especially when we get into Laplace transforms. You'll be doing a lot of integrals where you have to know partial fractions. Partial fractions decomposition. So you do need to know your techniques of integration. So in this problem here, you're going to have to integrate by parts. So let me give you some time to work this one.
Professor,
Yes.
I think someone in the chat asking you like if is like there any like practice problem for the integration.
Well, yeah,
Like
I do have practice problems.
yeah, I think he wanted is there any way can you put it like in the blackboard?
Uh, yeah, they are.
Yeah,
I do have practice problems on the different, like right now we're going to do integration by parts.
Okay.
yeah, that'd be if you have any practice problems, that'd be great because it's been several years since I've taken Calc 1 and Calc.
Yeah, that's what I found in the past is that sometimes you could be a really smart guy, but if you haven't taken calculus in a couple of years and then taken differential equations, it does make it difficult. But yeah, I'll show you where you could find the techniques that are important. See, one of the techniques that's important is integration by parts. That's why I want to do this problem here.
That'd be very helpful. Thank you.
Okay. All right. So let me go ahead and do this problem. So it turns out this is separable, right? That was solving separable differential equations. So in other words, I can get everything that's a function of x on one side and everything that's a function of y on the other side. Okay. And okay. So let's see. So now, so this whole parentheses here is squared, right? So this is an x squared here. This is an x squared, right? Yeah, let me actually not skip a step. I think in my notes I skip a step. Let me write it like this. Okay, so then I'm going to bring this x squared. Yeah, I'm going to bring the x squared over to here, right? So I'm going to have now x squared Oh, this is the x dy. Ah, wait a second. It's dy dx. So in this case here, yeah, I was this the x is on the top and the y is on the bottom. Okay, so then this is going to become okay, and now the y, I can bring the y down here, right? Does everybody see that? I got this y here, so the y becomes here. So now I separated it, right? I got this is a function of x here, and I got my dx, right? And this is a function of y here, and I got my dy. So now I could integrate both sides. Right. All right, let me just leave it like this for now. Okay, so now I can integrate both sides, and then I'll have my solution to the differential equation. Now, how do we integrate x squared times the natural log of x dx? Well, we do, yeah, we integrate by parts. That's right. So remember, when you integrate by parts, you have the integral of u dv is equal to uv minus the integral of v du, right? So in this case here, I'm going to choose u to be equal to the natural log of x, right? So then my du is going to be equal to 1 over x dx, right? And then my dv is going to be equal to x squared dx. And then my v is x cubed over 3. Okay. So I'm just working on this integral here. I'm not worried about this right now. I'm just working on this integral here, right? So we integrate this by parts where u is equal to, we can integrate this by parts if we let u equal to the natural log of x, then our du becomes 1 over x dx. Then this is our dv, right? Our dv is the x squared dx. So then that becomes v x cubed divided by 3. Okay. So this integral, I'll just do this integral here. This integral is going to be equal to my u, it's going to be the natural log of x, right? Natural log of x times v, which is x cubed divided by 3, right? X cubed divided by 3. And then I'll do it down here, minus the integral of v, which is x cubed divided by 3, right? Du, which is 1 over x. So this is 1 over x. So this integral turns out to be, well, let me rewrite this. X squared, the natural log. I'm gonna write it like this. Okay. Now this is going to be minus the integral of x squared, right? X squared over 3 dx, right? Because I got this x on the bottom. Okay. So now this integral becomes x cubed divided by 3, the natural log of x. And this is going to be minus x cubed, right? When I integrate this, I mean, x cubed, there's a minus sign here, right? It doesn't look like there is. So this is going to be x cubed divided by 9, right? And then let me put the c here. I'll put the c here. I got to put the c on one side. I'll put it here. All right. So that's this integral. All right. Now I still have to do this integral. I got to do the other side. All right. So let's see. So all right. So how do we do this integral?
Professor, that last integral, on the right side for the line 3, uh, negative, above that one, negative integral, x squared over 3.
Right, because here I got a 1 over x. Right? Let's see. See
Oh, I see.
the du, right? The du is 1 over x dx. Right? The du is 1 over x dx. So this is 1 over x. Right? Remember now, here's the formula. V times du. V times du. Or my v is x cubed divided by 3. Right? My v is x cubed divided by 3. And the du is 1 over x. So that's why this becomes x squared. Got that?
Yeah, understood.
Okay. All right. Now this integral here, let's see. This one's pretty easy to do. I can expand this, right? I can write this as x squared plus 2y plus 1, all divided by y, dy. And then I'll put it over here. Then I can write this as the integral. This would be y plus 2, right? Plus 1 over y dy, right? Make sure. Right? So I just expanded this and then I divide by y. So now I can integrate each one of these terms, right? So this is going to become y squared divided by 2, right? When I integrate this is going to become 2y, right? And then this is going to become the natural log of y. And I really should put absolute value. Y cannot go negative. Okay, so that's this integral. So now we're done. We're done. So we just put the two together. Let me get another sheet of paper. So so on one side, we have x cubed 3, the natural log of x, minus x cubed over 9 plus c, right? That's when we integrated the x, everything was on the x, and we integrate everything on the y, we have this. So that's it. That's the solution to this differential equation here. And here it is in my notes. Okay, I might have, I think I added a couple more steps. But see, here it is in the notes where, you know, we integrate this by parts. Okay, and okay, we choose u to be the natural log of x. And you know, if you choose them wrong, you're gonna get something more complicated, right? You know, if you end up making the dv this and the u that, so you want to choose your u and your v. There's actually rules. I guess maybe I could on what to choose for the u and the v. Maybe I can go over those rules. Okay, any questions? So this is, you know, the basic technique is that you get x on, you get everything as a function of x on one side, everything as a function of y on the other side, and then you integrate both sides. Now, we're not going to worry about this, but there are times, I'm not going to give any problems like this, but there are times when, then I'll stop the questions. There are times when maybe you get an integral that you can't, I don't want to do that one. Let's see. I don't think I gave any problems like this, but yeah. But just for the student that may be interested, you know, if you have something like this, okay, you can't integrate x squared, all right? So you would separate them out, and then you just leave it in the form of an integral, all right? So I'm not going to give any, I don't think, I'll check. I'm pretty sure I didn't give you any problems like this in the weather sign. But I just want you to be aware that sometimes you can use the method of separation of variables, but you may get an integral that you can't integrate. Like, you know, e to the x squared. there is a way of doing the definite integral, but an indefinite integral, this is an impossible indefinite integral to do. You can't do a definite integral though. So you could leave it like an integral form, right? So in other words, in this case here, you know, once again, you bring the x to one side and the dt to the other. Okay, but yeah, we don't have to worry about these. It's just you know, you would end up doing this numerically. Okay, let's see, where are we now with all right, there's one thing I wanted to do, which I forgot to do in one of the other problems. This is gonna become, you know, so right now we're doing separation of variables. Tomorrow, I'm going to do integrating factor. And then we're gonna go back and do autonomous differential equations and how to look at solutions, how we come up with solutions, how we can estimate solutions, but actually solve with not solving the differential equation. But one of the things I want to do, because I taught this course so many times before, a common mistake is that, and this is going to come up later on, especially with doing integrating. But if I have e 4 times the natural log of x, what is that equal to 4x, or is that equal to x to the 4th? I want everybody to understand, because I see this error a lot. This is x to the 4th, right? Because when I have e, I got to have the natural log right above the e. So in other words, this is the same as x to the 4th, right? And then when I take the inverse of the natural log, I get x to the 4th. So a common mistake is I see students write e to the 4th natural log of x as 4x. It's not 4x, it's x to the 4th, okay? So I hope you all understand that this is going to become, you're going to see things like this occur often when we do when we solve differential equations using integration factor. All right, let's see. I do want to do maybe one more. We got time for one more. All right, so that was solving a differential equation where we separated the variables and we had to use an integration where we had to use integration by parts. Okay. Something that's going to come up a lot, even when we get into Laplace transforms, is how to do partial fractions decomposition. All right, so I guess we got time for one more problem. Okay, I want you to try to solve this problem. I'll give you 5 minutes and then I should be able to finish it in time. And then we'll call it a day. Oh, yeah. Let's make it go through this point. So in other words, the initial condition would be 0, 1. So we also, this will be initial value problem where we want to find first we're going to find the general solution. And then we want to make it go through the point 0, 1. So that's the same as, you know, x is equal to 0 and y is equal to 1. So integration by parts and partial fractions are two techniques that you're really, or partial fractions decomposition are two techniques that are going to come up a lot. All right, let me go ahead and do this. I want to make sure I can finish this problem, and then maybe give you a few minutes for questions. Now, there's actually multiple. This problem is in my notes too, and all right. So once again, the first thing we want to do is get the dx onto one side of the equation and the dy on the other. So let's see. What I'm going to do is I'm gonna write it like this, right? Hopefully everybody can see I can write it like this. And then I'll bring the dx over here, right? I'm just bringing the dy down here, and then I'm bringing this over to the other side and writing it as dx over x, all right? So now I can integrate both sides, right? Because I got my y all on one side and I got my x all on the other side, right? Where I got the dx, I got my x. Where I got my dy, I got my y. So now I integrate both sides, all right? This integral is real simple to do, right? This integral is just going to be the natural log of x plus c. But how do we do this integral? Well, let's work on this integral here. Right. What I'm going to do is, well, let me do this. Let's take a look at this. All right. I could solve this integral by breaking this up into partial fractions, right? Hopefully you remember that from calculus 2. Where in calculus 2, well, first of all, I can write this like this. I can factor out the y, right? I can write it like that, right? And now I could break this up into a, say, is y minus 1, right, plus b over y. You remember, hopefully you learned how to do this in calculus 2, right? How to solve an integral with using partial fractions decomposition. By the way, partial fractions decomposition is going to come up a lot when we do Laplace transforms. So here too, I'm making sure that you know how to do the partial fractions decomposition. Okay. So, all right. So how do I find out what A and B are? Right. I have to find out what A and B are. I'm taking this here. I'm just looking at this. I factored out the y, and now I break it up into these partial fractions. So this is the same as 1 is equal to A times y plus B times y minus 1. Hopefully everybody understands that, right? That if I multiply, right? Actually, what we're doing here, you multiply by this, right? Then this becomes 1, right? When I multiply this whole equation by this becomes 1, right? This cancels with this, and you're just left with the y here. And then here you're left with the y minus 1, all right? So now I have to solve this equation for A and B, right? So the simplest way to do this is to, let's see, if I let y is equal to 0, right? If I let y is equal to 0, then this is 0, right? If I let y is equal to 0, this would be 0, and I'm left with 1 is equal to minus b, right? This is 0. I'm letting y equal 0. As opposed to solving the differential equation, that's an easy way to do it. You get rid of the constant a, right, by letting y equal 0. And then, so I'm left with the b is equal to minus 1. Now, if I let y equal to, if I let y equal to 1, right, then this is 0. And I'm getting that the a now is equal to 1, right? So that's it. So now I have my a and b. All right. Let me, I guess I could. So this integral now, let's see. This integral, I can write this integral here. I guess I could put it up here. This integral now is going to be equal to the integral of a, which is 1 over, and then minus, b was minus, right? So it's minus dy. Okay, so that's this. So I broke this up into partial fractions, and we got the A and the B, and so this is what we have now, and this is all equal to. Okay, so let me take another sheet of paper here. So now what I have to, so now I can integrate, now it's easy to integrate this, right? I can integrate this, all right? So you need to know partial fractions, all right? So what is this integral? Well, this integral, this is just the natural log of y minus 1, right? That's what this integral is. This is minus the integral of y, right? This is the integral of y, minus, no, equal to the natural log of x plus c, right? I need to put a constant. All right, so far so good. So now, let's see. I want to apply this initial condition. I want to get it in a different. I want to get rid of the logarithms. Actually, this would be okay if we wanted an implicit solution. This would be a good answer. All right, this would be a good answer if we're looking for an implicit solution. This would be. But if I wanted an explicit solution, I got to solve this for y, right? I'd have to solve this for y if I want an explicit solution. So let me go ahead and solve this for y to get an explicit solution, and then apply the initial condition that I have here. All right. Let's see. So let's see. So I can write this as the natural log using our property of logarithms as y minus 1, right, divided by y, right? Remember our properties of logarithms? If you got the minus sign here, you're dividing. If this was a plus, they'd be multiplying. And then this is the natural log of x plus c. Okay. All right. So now I can take the exponential of both sides, and I'll get take the exponential of both sides, and I'll get y minus 1 divided by y is equal to, I don't know if I should skip a step. All right, let me write it as e to the natural log of x plus c, right? Now this here, I can write this as x, right? I can write this as x times c. Hope everybody's, because this is the same as e to the, let me do it this way. In my notes, I skip steps. Here, I'm not skipping a step. So, so this is the same as, I want to make sure everybody understands. This is e to the natural log, right? And then e to the c. But then I can write that as e to the natural log of x. Gotta put the x in. Which then I can write this as c times x, right? So I want everybody to understand that's what this is. This is c times x, right? C times x. All right. So, so this is what I have now. I got y minus 1 divided by y is equal to c times x. All right, I want to solve this for y. So let's see, I can write this as y minus 1 is equal to c times y times x, right? Okay. Let's see. So I'll bring this, I want to solve it for y. So I'm going to bring this y over to the other side and bring the 1 over to that side, right? So all I did is brought this over to this side, this over to this side. Then I'm going to factor out the y. Okay, so now finally, I get that y is equal to 1 over 1 plus cx. So that's my general solution. That's my general solution to this differential equation. The general solution to, here's my differential equation, and this is the general solution, right? Here's the general solution. Okay, now I want to apply, so this is what I have here. Let me write this. I got y is equal to, okay. So I want to apply the initial condition that, that when this is equal to 1, let's see, it would be 0. Does that make any sense? Okay, I got the general solution, so if y is equal to 1, Let's take a look at something here. Was that the initial condition that I wanted to give you? Yeah, I'm missing a page. Okay, let's see here. Oh, okay. It's a little tricky. That's what I thought. So it turns out this is true for any value of C, surprising result. Because if I put in x is equal to 0, right? In other words, I have, yeah, if I put in x is equal to 0 here, right, and y is equal to 1, then this is, I get 1, right, is equal to 1 over 1 minus 0. So C could be anything. That's interesting. So C could be anything. So this is the solution to the differential equation. And also this is a solution that it'll always go through this point. It'll always go through that point, no matter what the value of C is. That makes sense because if let's say this is equal to 10, and this is 10. Yeah. Okay. All right. So this is one of the problems. So this is one of the problems so I want you to go through this. So see, this is one of the problems where you had different initial conditions, okay? Or different, we wanted to solve this differential equation, right? You have this differential equation you want to solve. And then what we just did was when it goes to the point 0, 1. So I also want you to look at 0, 0, right? And then 1/3, 1/3. And basically I have the solutions I've given you. But I want to make sure, I want you to go through this. This is 11. Okay, here we go. So you have the answers. I've given you the answers, okay? So I do want you to do these in WebAssign. So I've given you other problems where I haven't given you the answers and the solutions. So for example, this is the solution to A. So so in each one of these cases, this is the general solution, right? This is your general solution. And then you're trying to find the, after you get the general solution, you're trying to find C such that it goes through the point 0, 0. You're trying to find C that it goes through 1/3, 1/3. C that it goes through 6 1/8, and that's it. Okay. And once again, the solutions are worked out here. It's interesting. So to go to the point 0, 0, it's just y is equal to 0. Okay. So two techniques of integration that's important to understand is integration by parts and partial fraction decomposition. Okay. All right. So that's it for today. If anybody has any questions, I'll stay on. I hope that are you feeling comfortable with this? You know, now it's very important that you understand how to solve separable differential equations before we go into what I'm going to be doing tomorrow is how to solve. We're going to learn how to solve a differential equation tomorrow we'll learn how to solve a differential equation that looks like this. That is inseparable, all right? We'll learn how to solve an equation like this that's not separable. And also how to solve, and also initial value problems where we'll look at, and I have videos on this. I have videos on that. And we'll look at those videos and we'll solve some problems. Okay, and then we're gonna, it turns out this is, I've taught this course many times before, but it's the first time I'm teaching it over a 6-week period. So I might have put too much, material in the first week, but that's okay because I think in other weeks, maybe like I have a whole week to do power series solutions to differential equations, and I have a whole week to do Laplace transforms. And I don't think we're going to necessarily need a whole week to do those things. So if we don't do everything we need to do in the first 2 weeks, like I said, I've taught this course many times before, but it's the first time I'm teaching it over a 6-week period versus a 15-week period. Okay, well, actually 5 weeks, right? Is it 5 weeks or 6 weeks? I'm not sure. All right, so that's it for today. If anybody has any questions, I'll stay on, and have a good day. It looks like it's nice outside, and I'll see you all tomorrow.
Thank you.
Thank you. Have a nice day.
Thank you, Professor. Have a good day.
Okay, have a
Thank
good
you,
day.
Professor. Have a great day.
Thank you. Take care.